My name is Robert Douglas. I'm an undergraduate engineering student at the University of Sydney. In this video, I am going to explain how I am using MATLAB and Simulink to design a control algorithm for an autonomous surface vessel as part of my honours thesis. There are many different possible control algorithms that may be generated for such a vessel, but the majority are a variation on the classic follow the carrot algorithm. This algorithm uses the difference between the current heading and heading to target as an error term, typically as an input to a PID controller. The block diagram environment of Simulink makes an algorithm such as this extremely easy to model. In order to compare the performance of a number of different algorithms, a model of the physical system was generated in Simulink. The Marine System Simulator, developed by the Norwegian University of Science and Technology, is a Simulink toolbox which takes the parameters of the vessel being simulated, such as drag coefficients and thruster configurations, to generate a dynamic model. The force and direction of thrust can then be input to the model to give an accurate simulation of how the vessel moves over time. A block diagram for each of the control algorithms was generated, which takes the initial position and heading, the current position and heading, and a target position as arguments. This forms a subsystem which can be inserted into the dynamic model. The control algorithm provides the inputs to the model based on the position of the vessel in a 2D space. Each control algorithm was generated with common input and outputs, allowing modules to be easily replaced. A graphical user interface was developed using Guide that directly interacts with the Simulink model, allowing the user to set the initial and target conditions, along with the parameters for the PID controller in each control algorithm. Additionally, they are able to select a control system using this interface and begin the simulation. The PID parameters and target position can be changed in real time as the simulation progresses, allowing the effect of perturbations on the control algorithm to be determined. The logging capabilities built into Simulink allow easy comparison of the different control algorithms. The position of the vessel based on the same initial conditions but using two different control algorithms can easily be compared using the Simulation Data Inspector. Finally, the code generation toolbox built into Simulink allows the control algorithms to be easily integrated into an embedded system using generated C++ code. The same inputs may be used based on real-world sensors to produce an output that controls the thrust of the motor along with the direction of the motor. This allows what are relatively complex systems to be integrated extremely easily, reducing development time markedly.